Okay, so this video is going to be about Chapter 3 material. So again, hopefully you've had a chance to read Chapter 3. If you haven't, go ahead and pause this video. Take some time to read Chapter 3 first before you take a dive into some of the concepts and some problems. So I'm going to start by going over a few of the concepts that are in the textbook for Chapter 3 for displaying and describing categorical data. And then we'll do some examples, and hopefully you'll feel more confident before we have our first virtual class meeting with our Google Meets link. So again, hopefully you're watching this right before I see you guys in a virtual class. Okay, so let's start by just talking about contingency tables. So a contingency table, or a two-way table, that's another way to describe this table, allows you to look at two categorical variables at the same time. So a lot of the, pretty much all of the tables, contingency tables that you'll see in the notes here that I'm talking about are from the textbook example of looking at the Titanic, all right, and looking at the two variables from the Titanic that include the class of the ticket. So first class, second class, third class, and crew if they were working on the ship, and then whether they survived or not, so alive and dead. All right, and these are actually the real numbers. All right, so this is not one of those made up ones. These are the real numbers from the Titanic. Okay, so let's first talk about something called the marginal distribution. All right, and a lot of students are kind of stumped by this. It's a fancy word or a fancy phrase, the marginal distribution, but literally just means take a look at your variable that they want to know the marginal distribution for, and just look in the margin. All right, so in this case, they're asking for the marginal distribution of survival, such as how many made it, so how many are alive, and how many died. All right, for the conditional distributions, this is kind of getting more information. So they're saying, okay, if we look at the variable survival and we look at just those that died, what is the breakdown by ticket class? So that allows you to get more information, kind of drill down a little bit more into the difference in death rate based on their ticket class. All right. So ultimately, you're going to see, I'm going to show you guys a way to calculate using some statistics to determine if two categorical variables are independent or not. So again, independent, we're just going to kind of keep it pretty generic right now. This is our first discussion about independence, but just independent variables means that they have no interaction or no relationship with one another. Okay, so you'll see, and you probably already know from if you ever learn about the Titanic, that there actually is a relationship between your ticket class and whether you survived or not. And this graphical display here, called a segmented bar chart, can show you that very easily. If these two variables, class and survival, were independent, then the segmented bar chart, so the colors you see here, the green, pink, purple, and yellowish orange, they would look identical or close to identical for the alive and dead bar. All right, but you can see that if you look at the second bar for the those people that died, you can see that almost 45% of those that died were from the crew. And then if you take into account the third ticket class as well, third class, 80% of those that died were from the third class or crew. So you're talking about pretty much of those that died, almost all of them were from the third ticket class or crew working on the ship, all right, which is different than if you look at those that survived, right? That's almost more of an even breakdown, not precisely like the pink bar is pretty small, but ultimately the alive is more evenly spaced, and the dead one is very much purple and yellowish orange. So you can see that there is a difference. There is a relationship between class and survival. If your ticket class was third, or you were a crew member, then you were more likely to have died than first or second class. All right, so let's do some problems that demonstrate what we just went over with those concepts. So the first thing I want to do is look at this survey of cars that were parked in a student and staff lot at a large university. And they've given us some information. They've given us two categorical variables: the origin of the car, all right, and the driver classification. So student or staff, and the origin being American, European, or Asian. Now, what I noticed about this contingency table or two-way table is that it does not have anything in the margins yet. I don't have any totals for my margins. So let's go ahead and we'll calculate these totals. And while we're doing this, hopefully you know that we're basically calculating the marginal distributions for each of these variables. So I'm going to start with origin, 107 American student driver cars and 105 for staff to give me 212. Let's switch this, 212 American cars. All right, let's do that. Easier to read it. Okay, so I'm going to change this to 12. There we go. All right, now for European, we're going to have 45 total. And then Asian, we have 55 and 47 for 102. All right, let's go ahead and find the marginal distribution for driver. We have 107 for American students driving, American cars, plus 33, plus 55, which gives us 195. And then finally for staff, 105 plus 12 plus 47. That's 164. Now, one thing you can do to check to make sure you did your calculations correctly is to add up both of your marginal distributions separately, and you should get the same grand total number. So I got 359 when I added up the origin ones. Let's see what I get when I add up the driver. I get 359 as well. So we know those numbers match. So that's our grand total. All right. So let's use all of these numbers that we calculated and the given table to find some percentages. Now, what you're going to find out when you start doing these problems, when you're watching this video, when you start doing them on your own, is that these problems are just reading questions, right? There's so many students get these wrong because they don't read the question correctly. So listen to the emphasis that I put on some of these questions, all right? Letter A, what percent of all the cars, all right? So of all the cars, that's 359 cars. So what percent of all the cars surveyed were foreign, all right? So we're looking at, out of all the cars, 359, how many were foreign? So not American. So that's going to be European and Asian. And you'll notice that in this problem, we did not take into account anything about whether they were student drivers or staff drivers. So again, this is just looking at the origin. So I've got 45 plus 102 divided by 359, which gives me 40.9%. All right, let's do the same thing for letter B. What percent of the American cars? So now it's not talking about all the cars. It says of the American cars. That's 212 American cars. And out of those 212, how many were owned by students? So that's 107. I get every year a lot of students for this fraction, they'll write 195 over 212. All right, but once it tells you that they're just looking at the American cars, you're only focused on this row, right? So that's why it's not going to be the 195 for the student number. All right, so 107 divided by 212 is 50.5%. All right, and then letter C says what percent of the students? So of the students, 195 students, how many of those own American cars? So 107. You'll notice the numerator for part B and part C is the same, but the denominator is different based on the wording of the problem. All right, so that one's going to be 54.9%. Okay, let's move to the next slide. It's still about the same two-way table, so I'm just going to go ahead and fill in those same marginal distribution numbers that we calculated before. And our grand total of 359. All right, so in letter D, it says, what is the marginal distribution of origin? Well, we already calculated that before we even did any problems. The marginal distribution of origin is going to be the numbers. If you start with origin and move to the right into the margins, you'll see 212 are American, 45 European cars, and 102 Asian cars. Okay, Now, for what are the conditional distributions of origin by driver classification? I'm just going to say this one because it'd be too much to write in this little space. But if you want to write it down in your notes, you can. So for the conditional distributions of origin by driver classification, you're looking at, okay, just American. We had 107 students driving American cars and 105 staff driving American cars. Then for European, we had 33 students driving European cars, 12 staff driving European cars, and finally, 55 students driving Asian cars and 47 staff driving Asian cars. All right, so that's how you would answer part E. But I want to spend the last part of this, and it's going to take a while, but I want to show you everything to do letter F. Do you think that the origin of the car is independent of the type of driver? So when you're asked a question about independence, if you just write a sentence of like, yeah, I think they're independent, or no, I don't think they're independent, you have to back it up with some actual calculations. So let me show you how we're going to do that. All right. And I'm going to show you many examples. This is just one of many. All right. So the first thing I tell students is to pick one of your two variables. All right. So whatever you want, doesn't matter. Just pick origin or driver. Personally, I'm going to pick driver. Okay. So if I just pick driver, so I'm ignoring anything about the origin of the cars. All right, how many students and staff, all right, and those percentages. So out of 359 cars, how many were students? 195. Out of 359 cars, how many were driven by staff? 164. So if I get those two percentages, 195 over 359, that's 54.3%. And then for the other one, 164 divided by 359, that's 45.7%. And you'll notice that those will add up to 100%. So far, I haven't done anything that brings in origin. And we're just saying out of all the cars in the parking lot, 54.3% are driven by students, 45.7% driven by staff. Okay. So now when I bring in origin, I'm going to look at American. I'm going to look at European and Asian. When I calculate, all right, out of just the American cars, so that's 212 American cars. When I calculate how many are student and how many are staff, I do the same thing for European. Out of 45, 33 were student. Out of 45, 12 were staff. And for Asian, out of 102, 55 are student and 47 are staff. When I calculate these percentages, all right, if they are not very close, all of them very close to the 54.3%, 45.7% split for student and staff, then I will know that there's a relationship. They are dependent of each other. All right. They're not independent. So I have to see all the numbers, right, for student and staff by origin, basically the same as these two up here, these original up here, when I don't factor in origin to determine if they're independent. Okay. So let's do some calculations. 107 divided by 212 is 50.5%. All right, so that means the number for the percentage of staff driving American cars. I guess I should say the percentage of the American cars driven by staff is 49.5%. Right now, literally my first one I calculated, I'm going to zoom in over here. My first one I calculated is more 50-50 than the original I calculated for students and staff without bringing in origin. All right, so right there, I'm already determining that these two variables of origin and driver classification are not independent. Because if they were independent, then these first two I calculated should be roughly 54 or 46%. Let's keep going to finish the statistics that I'm calculating here. Wow, this one is way different. 73.3%. And 26.7%. So now when I look at just the European cars, you've got a much higher percentage of students driving European cars than when you look at just the percentage of students and staff owning cars in the parking lot. So that is even more apparent that there's a relationship here. All right, and finally for the Asian cars, we have 53 0.9%. 47 over 1 and 2 is 46.1%. Now, that one actually is fairly close. That's less than a percentage point away than the original. So if if all of these percentages were in that range that I found when I did the Asian calculations of about 54% and 46%, I'd feel pretty confident saying that they're independent. But I'm going to say that they're not independent. There is a relationship, and it looks like if you tell me that the car is a European car, it's more likely to be driven by a student than a staff member. So just keep in mind when you're having to answer these questions for me on the exit ticket and on the quiz that I'm going to be looking for all of these calculations, as well as some sentences about why you think they're independent or not. Okay, so I know there's a lot there, but just keep in mind we're going to do many more examples and you'll become more confident in that. Let's do some more calculations real quick and then we'll be all finished and you can hopefully have questions for me before we meet virtually. All right, this time in this two-way table for gender and politics, I've actually put some spaces to calculate the marginal distributions. So we have how many students are male. We've got 12 students are male. For females, we've got 13 for a total of 25 students. And how many consider themselves to be liberal? 5, moderate 18, and conservative 2. Excuse me. All right, so what percent of the class? All right, so of the class, that's the entire class of 25. What percent of the class consider themselves female with liberal political views? So that's going to be just one person. All right, so if you get a percentage for 1 out of 25, that's 4%. All right, what percent of the liberals, all right, so how many liberals are there? 5 are female. That's still just 1, so that's 20%. What percent of females, so that's 13 females, are liberals? So still that numerator of 1, but the denominator has changed to be 0.08%. I'm sorry, that's completely wrong. 7.7%. Math is hard. Okay, let's move to the next one. So on this one, I'm going to fill in those margins again. We got 2 conservatives, 18 moderates, and 5 liberals. All right. What percent of the males in the class, so of the males, so there's 12 males, consider themselves to be moderate? So that's 7 out of 12. That's going to give us 58.3%. And then what percent of all students in the class, so there's 25 students in the class, are males who consider themselves to be moderates? So males and moderate is 7. So that's going to be 28%. All right. So again, I know I went pretty quickly there. You'll get a lot of time to practice and go over these videos if you need to. But again, the biggest thing is just read the question to help you determine what the denominator is first. All right. So like of the class, that's all the students. Of the liberals, that's just the liberals in the denominator. Of females, that means females are in the denominator. So determine that denominator first before you move on to pick what's in the numerator. All right. See you guys soon.